up, guys? Welcome to this page of the notes, and let's go ahead and just jump right into graphing one of these quadratics to find my solutions, right? So here's what I've done. I've given you a quadratic. It is an equation because it is set equal to 0, but I ask you to graph it. So what you're going to do is actually graph it. Again, you can call it whatever you want to. I'm going to call it f of x. We're going to graph f of x is equal to x squared minus 3x minus 4. Again, it doesn't hurt to just go ahead and right away write out your general form ax squared plus bx plus c. And again, originally I gave you that equal to 0. My a, my b, and my c are integers. It is in standard form. So we're all set to just go ahead and jump right into this. Now, in order to graph, normally what we do is we set up an xy table. We would set up x, y, and you would plug in values, right? You would choose values of x that you could then plug into the function to get your y values. And normally we like to do -2, -1, 0, 1, and 2. Not because there's anything special about them, but just because they're easy to do math with. Well, unfortunately, when it comes to quadratics, that is not going to be the way that you want to go. Actually, in order to set up this table, you're always going to start with the axis of symmetry. So that's what I'm going to need to find first, my axis of symmetry. Let me go ahead and get rid of this table. We'll come back to it. But since I don't know where my values of x need to start, I got to do my axis of symmetry first. So let's do that. Remember, x is equal to a -b over 2a. Okay, well, my b is a -3. So minus times a -3 would be a +3. My a is a 1. So I'm going to have +3 over 2, or 3/2. Now what we're going to do, and remember, as a decimal, right, that's 1.5. Now what we're going to do, this is going to be the very first value that I'm going to plug into my xy chart. So let's go ahead and get that set up. X, y. And again, 1.5 is going to be the first value that I'm going to plug into my chart. And make sure that you put that value in the middle, because what you're now going to do is you're going to choose values greater than 1.5 and values less than 1.5. Because remember, the parabola is symmetric, right? From that axis of symmetry, it'll either open down symmetrically on both sides, or from that vertex, that axis of symmetry, it'll open upwards symmetrically on both sides. Well, since this is my axis of symmetry, I know that my parabola will start here. And it'll either open, actually in this case, because a is positive, it will open up from this point on either side of that axis of symmetry. Please do not think that because your vertex is at a decimal, which ours is 1.5, that you have to put decimals in your chart. It's crazy. That's way more work than you need to do. We want to pick numbers that are simple. So from 1.5, the next easiest number to use that's bigger than 1.5 would be 2. And then I would do 3. Let's see, how far did I go? I went all the way to 6. 4, 5, and 6. In the other direction, go to -3. So it would be 1, right? Because the next easiest number less than 1.5 would be a +1, 0, -1, -2, and -3. Now remember, again, like I just mentioned, parabolas are symmetric around that axis of symmetry. So here's all you need to do. You only need to do from your axis of symmetry in one direction, right? Either axis of symmetry up or the axis of symmetry and down. right? Because what's going to happen is 1 and 2 are going to be mirror images. The y values are going to be exactly the same. That's how you get that nice parabola that's symmetric around the axis of symmetry. 0 and 3 are going to have the same y value. -1 and 4, same. -2 and 5, same y value, right? So once you find either the top half or the bottom half, you just go back and fill in the rest of the chart. That's how you get that nice symmetric parabola. I'll show you when we graph it. Let's go ahead and jump right into doing these. Again, you're going to plug the x value into the equation that you were given. Don't fat finger something on your calculator. 1.5 in for all the x's. I actually did this one ahead of time because it was a decimal, and it comes out to be a -6.25. -6.25. Again, double check, make sure that you get the same thing that I do. But here's what I know. This is my vertex. Okay. I'm actually going to go up because I think these numbers are going to be a little bit easier to work with than these ones down here. Nothing wrong with doing these ones, but I like those ones better. So here we go. I plug a I plug a +1 in everywhere I have an x. 1 squared would be 1. -3 times 1 would be a -3. -4, -3 minus 4 would be a -7, right? -7 plus 1 would be a -6. Well, since this is a -6, 2 must also be a -6. Because remember, that parabola is going to be symmetric on either side of the axis of symmetry. If this is my vertex, these points have to have the same y value in order for that symmetry to show up. 0. Plug a 0 in for each of those x's. This is easy math. 0, 0, -4, so I'm left with -4. And whatever 0 is, 3 has to be the same. -4. Also, let me stop you here, because what we just found, whenever x is equal to 0, you just found the y-intercept. So let's label that. The point 0 whatever is going to be the y-intercept, where your parabola crosses the y-axis. Awesome, let's keep going. I'm going to plug in a -1. -1 squared is a +1. -1 times a -3 would be a +3. I have 1 plus 3, which would be 4. And 4 minus 4 is 0. So 0. And whatever -1 is, 4 will be the same. 0. Well, here's what's interesting, right? Whenever the y value is 0, right? When y is 0, you are crossing the x-axis. So we just found them. This guy right, I want this one. This guy right here and this guy right here represent my x-intercepts, right? So this is an x-intercept. This is an x-intercept. They represent the zeros, right? The zeros of the equation, or the roots of the function, all right? Zeros or roots, in either case, they're both representing x-intercepts. Let me just finish off my chart. If I plug in a -2, I wind up with 6. And of course, the 5 has to be the same. And if you plug in a -3, you would get 14. And of course, the 6 has to be the same, 14. Now, this doesn't fit on my graph, right? My y only goes to +10 and -10. So technically, I'm going to leave those ones out because I can't graph them, but I can graph the rest of them. So let's go ahead and do that. 1, -6. Let's see here. 1, 2, 3, 4, 5, 6. There's a point right there. I would also be at 2, -6, 2, -6. I've got this point, 1.5, -6.25, which is going to be somewhere right in there. Somewhere right in there. All right, my next one, 0, -4. That's my y-intercept. 0, 1, 2, 3, right there is where I cross the y-axis, and I also be at 3, -4, right? Because this point and this point are mirror images of each other, there and there. I have -1, 0. This represents one of my x-intercepts. I also have 4, 0. Again, because this one, this one, -1, 0, and 4, 0 are mirror images of each other, right? When I draw my parabola. -2, 6, -2, 1, 2, 3, 4, 5, 6, and 5, 6, 5, 6. And then what we'll do is go ahead and draw my parabola through each of those dots. Make sure you extend your lines all the way through the coordinate plane. Put arrows on either end so I know you know that that guy just keeps going. Feel free to put that axis of symmetry in there if you would like. You'd only have to graph it if I ask you for it. In this case, I didn't, but I'll go ahead and throw it in there so that you know what it looks like if I ever do ask you for it. But here's definitely what I will ask you for in the problem. Let me slide up just a little bit. I am going to ask you for the roots. Well, in this case, right, you've got two of them. Roots represent the x-intercepts, which is going to be at -1, 0, and at 4, 0. I will ask you for the vertex. Well, the vertex is at 1.5, -6.25, 1.5, -6.25, and finally, I will ask you for the y-intercept, which for us was at 0, -4. Once you have found, once you have filled in that XY table, everything I will ask you for, the graph, the roots, the vertex, the y-intercept, everything comes from this table, all of it, right? So what you need to do is make sure that you take your time, fill in that table correctly by starting with your axis of symmetry. That'll be the first point. Go a few in both directions. Again, you only have to do half the chart because the other half will just be the mirror image. The y values will be the same. And once you've got that chart filled in, everything I'll ask you for comes right off of that chart. Guys, I hope you had a good time doing this problem. I really like these a lot. I think they make sense. It's a nice, easy problem to work through where the math doesn't get too difficult, but you're doing something really, really fascinating. So head on over to the next page of the notes. We'll try a few more of these, and I'll meet you guys there.